Hello smart people and welcome. Let's resolve this particular problem. So we need to find the equivalent capacitance in this particular circuit. How do we go about it? Pay attention to these two. They are connected in series. So for serial connection, let me just number this. Let's say this is point P, point Q, point R, point S. P, Q, R, S. All right. So this capacitor at this particular position, P and Q, they are both connected in series. What is the formula for serial connection? 1 over C for this particular capacitors will be 1 over the first one plus the inverse of the second one. Now, how do we get this guy? Not the inverse. How do we get CPQ, which is this particular capacitors connected in series? It's pretty simple. Just make sure you solve for this particular fraction. 1 over CPQ equals, the denominator are the same, just pick one of it and then add the numerator. The numerator is 1 plus 1. So we have 2 over C. So remember, we are not looking for the inverse of this CP. We are looking for the total capacitance of these capacitors connected in series. So you have to flip this, turn it upside down. So we have CPQ divided by 1, which is the same thing as this, equal to, if you flip this, you have C over 2. So this is the answer for this particular guy. So I want to redraw the circuit. That's how I simplify circuit problem. If I redraw the circuit, I'll have to represent this and every other thing. So we continue from there. So what this circuit becomes, this is what it becomes. We have this guy. Let me shift it a little bit. This guy is the one you're having here. This answer you have, that is this. You have C over 2. And then what about this guy? We have it somewhere here. So that is for C. And then what about this guy? Is still there. I've not worked on that one. We have C. Remember, that's point R. This is point S. And this point is this particular point, CPQ. And this one is this one, A and B. You can see that I've reduced the circuit from this point to this particular point. So what's expected of me is to solve this. This is connected in parallel. So I'll have to solve this particular parallel connection. How do I get that done? The formula. The formula for parallel connection is C. Which point am I working on? This particular point, CPQ, and this particular one, S. So for C, how do I represent it? Let's use SPQ. Let's put it that way, because I'm working on these two capacitors. So don't bother about this representation. You can use maybe I, or we have gotten AB. You can use other alphabet to just represent that so it doesn't confuse you. I'm interested in these two capacitors. That's essentially what we're doing. So for parallel connection, this is the formula. This guy, the equivalent of this guy is equal to C over 2 plus this particular C. That's what I'm interested in. So let's solve this. If I make this over 1, it's pretty simple for me to get the answer. CSPQ will be, if you look for the LCM of 2 and 1 is 2. If you don't want to do LCM, you can cross multiply. 1 times C is C plus 2 times C is 2C divided by 2 times 1, 2. The same thing as looking for the LCM of 2 and 1 to be 2. 2 divided by 2 will be 1. 1 times C is this C. 1 divided by 2 is 2. 2 times C is 2C. That's another method. But what I did was just to say shortcut. 1 times C will be C. 2 times C will give us 2C. 2 times 1 gives us 2. Shortcut. And I know you like that. So here, C plus 2C will give you 3C divided by 2. We don't need to flip anything because this is what we are looking for. Okay, so let's redraw the circuit again. Now I've resolved these two guys and I got this particular answer. So that means the circuit becomes, this is the point A, and I have this to become this single capacitor, which is 3C over 2 connected to this other one, which is just C, and that's point R, and then this is point B, point A. You can see that I've resolved this parallel connection, and then it is now in series with this particular C, which is what you're having now. So we cannot solve this serial connection again, just like the way we did for this particular serial connection. That's pretty simple. So somebody will ask, why don't we do this? These guys that they're not in series, they can't do it that way. That's how I have to do it part by part. So for the serial connection, we use the formula 1 over, let's use the C equivalent. That's C total, because that's the total thing you're calculating for. C equivalent. EQ is for equivalent. Equal to 1 over this guy, which is 3C over 2 plus